we want to present about differentiation. So first, what is differentiation? Differentiation is the process of finding the derivative of a function or the process of finding the rate of change of one quantity with respect to another. When do we use differentiation? What are the applications of differentiations? So first, analysis of a function. Second, find the maximum and minimum value of variable. And third, to solve the related rates, which is the topic of our presentation today.
So now we will move on to related rates. What are related rates? Related rates is a concept when two related quantities are changing over time, the rates at which the quantities change are related. For example, when a balloon is being filled with air, both the radius and the volume of the balloon will also increase. Thus, the rate of change in the volume is related to the rate of change in the radius. So when do we use the related rates? Actually, we apply related rates in many ways in our lives on a daily basis. Hence, there are many real-world applications of it. The examples of it are when a snowball is melting, a balloon is being blown up, or when a stone creates a circle ripple in a lake. Moving on to related rates problems. Usually, in a related rate problem, we are asked to compute the rate of change of one quantity in terms of the rate of change of another quantity. The steps in solving related rate problems are as follows. The first step is to read the problem carefully and write down all the given information. Next, sketch and label a graph or diagram if applicable. The third step is find an equation that relates the unknown variable and known variable by looking for geometric shapes, known formulas, ratios such as the Pythagorean theorem, area and volume formulas, or trigonometric identities. Next, simplify the equation using appropriate substitutions so that the chosen equation has only two variables, the known variable and the unknown variable. Then, differentiate the equation implicitly with respect to time. Lastly, substitute all known values into the derivative and solve for the final answer.
Problem statement. A conical water tank has a radius of 5 cm at the top and 20 cm high. Water flows into the tank at the rate of 4 cm³ per second. How fast is the radius changing at an instant when the height of the water is 6 cm? Solution. There are several steps to solve this question. Step 1. We have to find the rate of change given. The given rate of change is dV over dt, which is equal to 4 cm³ per second. Why the value of dV over dt is positive? It is because the question states that the water flows into the tank, which means the waters in the tank will be increased. So the value of dV over dt will be positive. Next, we have to find the dr over dt when the height of water is equal to 6. The second step is we have to find the related equation. In this question, we use the equation volume of cone, which is V equal to 1 over 3 pi r power of 2h. And we also use the equation of r over h, which is radius over height, equal to 5 over 20, and simplify the h equal to 4r. The third step is we have to substitute with the values. To find the value of dr over dt, we have to use the chain rule, which is dr over dv multiplied by the dv over dt. And in the previous step, we have find the dv over dt values. So we just substitute the dv over dt values into the equation of dr over dt. The fourth step is we have to insert all known values in the equation. Now we have two equations. The first equation is the volume of cone, and the second equation is h equal to 4r. Next, we have to substitute the H value for the equation of cone 2 for R, which is V will be equal to 1 over 3 pi R power of 2 in bracket 4R, which is the value of H. And then we will simplify, we will get the answer 4R power of 3 pi over 3. Then we will have to differentiate the value of V, and we will get the answer dV over dr equal to 4 pi R power of 2. The last step, we have to solve the remaining equation. So now we have to find the value of dr over dV. But in the previous step, we have find the value of dV over dr. So to find the value of dr over dV, we have to divide 1 by dV over dr. So dr over dt will be equal to 1 over 4 pi R power of 2 multiplied by 4. And simplify it, we will get the answer 1 over pi R power of 2. Next, we have to substitute the value of H into the equation H equal to 4R, and then we will get the R value equal to 3 over 2. And the last step, we have to substitute the R value into the dr over dt equation. So dr over dt equal to 1 over pi in bracket 3 over 2 power of 2. And then the final answer, we will get dr over dt equal to 4 over 9 pi centimeter per second.
As a conclusion, the solution we use to find the value of rates are successfully. This formula can be used to solve various types of problems in the real world. For example, as we had already shown in our previous presentation, it can help us to calculate the accurate rate of a charge in the radius of a conical container when a water is being poured into it. Lastly, people use differentiation in almost everything, hence it is quite important to understand its concept so that we can apply it in our life. So, I hope this video can help everyone to understand more in this topic. Thank you.